Okay, hello everyone. Let's start properties of inverse trig functions, lesson number 3. And from trig functions, hopefully you have a high motivation and high confidence and no fear. Okay, first one, inverse sine minus x. Now we need to prove that's what it is. I'm gonna go let y equals inverse sine minus x. Okay, watch this carefully what I'm doing. So I'm gonna make this using this to prove this. So I'm gonna move this aside, inverse sine into the other side, becomes sine y equals minus x. Okay, and then I'm going to write x equals minus sine y. Okay, I've just swapped that around and times by minus 1. And what is this one? Now with the range of sine, it's in the first and the fourth quadrant, isn't it? Yeah, because what's a range? It's minus pi over 2, pi over 2. Now if you have any problems, watch my other videos on lesson 2. I explain this in there. And when negative value from here, when we look at here, sine y equals negative x, which will give us a negative sine value, fourth quadrant, yeah. So with the fourth quadrant, it's a negative theta, isn't it? Because it's going from 0 to minus pi over 2. So it's going to be negative acute angle here. So that means I can write like sine minus y. I can rewrite like this. So what's happening here is, so I will go and then move this one back, because what I'm going to do, trying to make y the subject here. So I'm going to go inverse sine x equals minus y. Okay, do you understand this? So, and then what I'm going to do is make the y the subject. So I'm going to rewrite like this, so it'd be easier for us to look at. And I'm going to make y equals minus sine. Okay, so it'll be y equals minus inverse sine x. Okay, now, but we said at the beginning y equals inverse sine minus x also. So therefore these two are equal. So now I can say sine inverse sine minus x is the same as saying minus inverse sine x, and we just proved that. Okay, well done. Next one, I'm going to prove this. Inverse cos negative x equals pi minus inverse cos x. Okay, so same thing happens. Let y equals cos negative, well, I'm just going to say negative 1, but it's actually inverse cos negative x. So I might just change the pen color so that we can see a little bit better maybe. So I'm going to move this one to the other, so it'll be cos y equals negative x. Okay, so that means, what is it? Cos was first and second quadrant, wasn't it? Because the range was 0 and a pi. Okay, so but cos is a negative, that means second quadrant. Okay, second quadrant is what? Pi minus y. So I can write this x equals minus cos y. That minus indicates it's in the second quadrant. Yeah, I can rewrite this into cos pi minus y, because it's in the second quadrant. Yeah, so I'm going to make this the y equals y the subject. So I'm going to move this one to this side. So it'd be inverse cos x equals pi minus y. Okay, and then I'm going to swap this because I want it to be y equals, don't I? So it'd be y equals pi minus inverse cosine x. But what do we say? We said y equals inverse cos minus x as well. So that means they are the same. So I'm going to say inverse cos minus x equals pi minus inverse cos x, like what we did here. Okay, so that was a proof for that. Next one. Inverse 10 minus x equals minus inverse 10x. Okay, so it's going to be the same as before, like most likely will be like sine. Okay, why? Because the range of the cos will be minus pi over 2 to pi over 2. Oops, I don't know why it's out of focus. Yep, that's better. Sorry about that. And then I'm going to go let y equals inverse 10 minus x, and I'm going to move this one to the other side. Okay, so we know that it's going to be first quadrant or fourth quadrant, and it's going to be negative, has to be fourth quadrant. Fourth quadrant is negative theta, right? Negative acute angle. So let's have a look at this. I'm going to move this one, minus 10y. And because in the fourth quadrant, it's going to be just minus theta, which will be same as saying 10 minus y. Okay, and therefore I'm going to move this one to the other side to be inverse 10x equals minus y. And I'm going to go y equals minus inverse 10x. But we said y is inverse 10 minus x. So they're the same. So I can say, therefore, inverse 10 minus x equals minus inverse 10x, just like that. Okay, so we proved it. Next one we have to prove is inverse sine x plus inverse cos x equals pi over 2. Well, let's have a look. I'm going to have a look at the left hand side here. Okay, proving. So let's have a look. I'm going to call y equals, and hang on a minute, nope, I'm going to say, yeah, sine x, and then y equals that, and that would be sine y equals x, and then I'm going to use the complementary angles. So this one will be sine there. So which one will give us positive? So first quadrant. So it's in the first quadrant, okay, and because the range was, okay, so what's happening is I'm going to use complementary angle. Results. Okay, so I'm going to go x equals cos pi over 2 minus y. Okay, so do you remember sine theta equals cos 90 degrees minus theta, or cos theta equals sine 90 minus theta? Okay, So what happens here? ABC, ACB, that's theta. So here is 90 minus theta, isn't it? Right? By angle sum of triangle. So if I ask you to find sine theta, you will go C over B, wouldn't you? Yeah. And also I say cos 90 minus theta. If I ask you to find it, it'll be also C over B. So therefore we can say sine theta equals cos 90 minus theta. Okay, so because they're both the same. Alright, so I can say that sine y equals cos pi over minus y. Okay, so that's not bad. So I'm going to go with that. And oh, I'm going to make this one move this one because I need something to replace this. So I'm going to go cos inverse cos x equals pi over 2 minus y. And I'm going to make it into 2. So I'm going to substitute this 1 and 2 into the left hand side. So substitute 2 into left hand side expression. So when I do that, it will be y plus pi over 2 minus y, which will be pi over 2, same as right hand side. Okay, so that wasn't too bad. Now I'm going to actually do some proving here. Okay, so let's hope we can do some proving smoothly. Show inverse cos minus 1 equals pi minus cos inverse cos 1. So I'm going to go with the left hand side. So inverse cos minus 1. I'm going to go, it's negative. It's going to be, or you can look at this. Okay, negative 1 will be pi. So that's my pi. And then I'm going to go right hand side will be pi minus inverse cos 1. Okay, what is inverse 1? It'd be 0, isn't it? 0. So pi minus 0 is pi, which is left hand side. Okay, as required. Next have a look. Now by looking at this, it's the proof number 4, isn't it? Inverse sine x plus inverse cos x equals pi over 2. So you know it's going to be true, but we just have to prove it. So I'm going to go let a equals inverse 4 over 5 and b equals inverse cos 4 over 5. So I can write a sine a equals 4 over 5, cos b equals 4 over 5. Okay, and I'm just going to sketch right angle triangle right now with a. So it'll be 5 over 4. If I do that, it'll be b here. Okay, the other way around. So a plus b equals, which is angle wise it's 90 degrees, which is pi over 2. So we substitute, so we're going to put it back into that. So if I do that, the left hand side, I'll go a plus b, which is pi over 2 right hand side. Okay, because I said let a equals that. That's my a, that's my b. I'll put it in. I know a plus b is pi over 2, which is same as that. Okay. Part C, very similar, but I'm not going to use what I've done with the let a equals that, let b equals this, because this is the exact value, which is easier to substitute. So I'm going to go inverse sine equals, we could use the same as b, but I'm not going to use it because it's exact value. So left hand side dot inverse sine half equals pi over 6, isn't it? Because inverse 30, sine 30 is half, so that's pi over 6. And cos as 1/2 is 60. Cos 60 is half, so it'll be 3. So I'm just going to put that in there. Left hand side, you do that, you get pi over 2, which is same as right hand side. Okay, that was not bad. Now it's a true or false questions. Let's have a look whether it's a true or false on this one. So I'm going to do inside first. So here I will do left hand side first, but this part first. So inverse sine 1 is with a sine. When do we get 1? Pi over 2. So that's my pi over 2 here. Okay, so it means therefore sine pi over 2. When you get pi over 2, it'll be 1, which is right hand side. Okay, so that's not too bad. So it is true. Let's have a look at next one. So true or false? I'm going to do the inside bit first. So sine 2 pi over 3 is in the second quadrant. So that means sine pi minus pi over 3. Okay, that means sine pi over 3, and it's positive. Sine pi over 3 is the sine 60, which is root 3 over 2. Okay, so therefore inverse sine root 3 over 2 equals, that's a sine 60 will give you root 3 over 2, so pi over 3, which is not the same as 2 pi over 3 up there. So it's false. Okay, next one. Inverse cos is that. So I'm going to do this one, left hand side first. So let me see, cos minus 3 pi over 4. Now this is not inverse, I can use all the things, but this is going to be second quadrant, isn't it? Because 3 pi over 4, which is second quadrant, and it's going to be negative. So it's going to be cos pi minus pi over 4 will give us 3 pi over 4. I'm going to go minus cos pi over 4. Why is it minus? Because it's a second quadrant, which is minus 1 over root 2. So if I put it all in here, inverse cos minus 1 over root 2, it's in the second quadrant, because at 0 pi, it's negative. Which one will give us negative? Second quadrant. So my answer will be 4, and it'll be 3 pi over 4, which is not equal to minus 3 pi over 4. So it's false. Okay, and the last question I'm going to go with, it's okay, so the left hand side, so I'm going to go inverse 10 minus 10 is, now be careful, you need to use mode radian, so I put it in a radian. Shift mode give you the number 4 radian. Okay, so radians, so if you go shift 10 exactly and then put minus 10, will give me minus 1.4711 something something. Okay, so whole thing is like that. So I'm going to go 10 minus 1.4711 dot 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 will be, so I'm going to go and that 10 answer will get minus 10. Okay, so don't cut it off 1.47, just put the whole thing together, which is same as right hand side, and therefore it's true. Excellent. So remember, put it in a radian mode. So make sure you watch this more than once and understand how to prove and how to use inverse function, trig function range. Okay, well done.